Hi, everyone. Welcome to our next video about hypothesis testing. In this video, we're going to talk about how we tell which test we're going to use. So here we have a decision tree for deciding which of the hypothesis tests we want to use, which distribution is appropriate. So the first thing we're going to ask ourselves is how many groups are we looking at? Are we looking at a single population or a single group, or are we comparing two groups? If you're only looking at one group, the next thing you're going to ask yourself is, are we testing a claim about a mean? If the answer is no, the only other thing we're talking about is a proportion, and you're using a one prop z-test. If it is a claim about the mean, you have to look at the standard deviation next. Do we know that population standard deviation? Just like with confidence intervals last week, if the answer is yes, we use a z-test. The answer is no, we use a t-test. And I'm hoping that those formulas in those boxes look familiar. Those are the same z and t scores that we've been looking at for the last few weeks. Z-test for a mean, t-test for a mean, z-test for a proportion, very similar to confidence intervals for those three quantities. If we are comparing two groups, we're going to go through a similar decision tree. So first thing we're going to ask ourselves is this a claim about a mean? If not, we're in the realm of proportions. We're doing a two proportion z-test. If it is a claim about a mean, do we know the standard deviations for the population? If the answer is yes, it's a z-test. If the answer is no, it's a t-test. These formulas look absolutely terrifying. And you'll notice as we go from left to right, they get more complicated. The good news is that because we are living in 2023, we have calculators that will do this for us in the background. So I'm only going to do one or two examples where I do this by hand. For the most part, I'm going to be showing you how to do this on a calculator so that you can avoid a lot of the headache, particularly with those two sample tests. Conceptually, you'll notice they're very similar to the one sample test, but in terms of the mechanics of evaluating them on a sheet of paper or by hand, it can be a little bit more difficult. So the big important thing in this tree is understanding one group or two groups. Is it a proportion test? Then it's a z-test. If it's a test about a mean, we look for standard deviation. We know the population sigma, it's z. If we don't, it's t. And as I mentioned before, those requirements are the same requirements we were using to do confidence intervals last week. The assumptions that we made regarding confidence intervals last week are also some of the same assumptions that we're making this week for hypothesis testing. So we made assumptions about random sampling and needing the underlying population to be normal or having a sample size greater than 30. All of those requirements that we mentioned last week with confidence intervals still apply this week with hypothesis testing, because the underlying statistics for both hypothesis testing and for confidence intervals is the central limit theorem. All of this inferential statistics that we've talked about so far is built on that central limit theorem. And so there are some assumptions we need to make in order to use that and do these processes. The upside is for your textbook and for this course, it is safe to assume that all of those conditions have been met. So you don't have to worry about that while doing the hypothesis testing here. But if you continue on to be a researcher in your field, those are those assumptions you're going to need to go back and check at the beginning of your study before you do the data analysis. Okay, I'm going to post this decision tree on our Canvas page for week 5 so that it's easily accessible and you can use it during your homework and your tests for this week. Again, if you have any questions, feel free to contact me via email or drop by my office hours. Otherwise, I will see you in the next video.